Okay, so in this lesson, we're going to discuss linear functions, but first I'm going to start by recalling some main characteristics of straight lines that you already know from previous years. Now, you know that the gradient, which means the slope of the straight line, is defined by the quotient of the vertical change divided by the horizontal change between 2 points on the straight line. As you can see here in this diagram, we have the point of coordinates x1, y1 and the point of coordinates x2, y2. So y2 minus y1 represents this vertical change between the 2 points, and x2 minus x1 represents this horizontal change between the two lines. So the vertical change divided by the horizontal change gives the slope of the straight line and what we also call the gradient of the straight line. Now, recalling quickly the different equations of straight lines. Now, oblique lines are the lines that are not vertical nor horizontal. So over here, oblique lines, is similar to the one in the graph here, can be represented using the slope-intercept form, y equal to mx plus b, where m is the slope and b is the y-intercept, or using the point slope form of the straight line that uses the slope and the coordinates of any point on the line. For example, here I decided to choose the point x1, y1. So it's y minus y1 equals to m into x minus x1. So what we would do here is replace the slope by its value, x1 and y1 by their values, and that leaves you with the equation of a straight line in terms of y and x. Now, regarding the particular lines, horizontal lines have their equation in the form y equal to b, because the slope for horizontal lines is equals to 0. So it would be simply y equal to the y-intercept of the line, while vertical lines have an equation of x equal to a. Now, the slope of vertical lines is undefined or infinite, so the vertical lines would be represented by an equation in the form x equals to the x-intercept of the straight line. Now, two lines of respective gradients m and m prime are parallel when their slopes are equal, when m is equals to m prime, or are perpendicular when the product of their slopes is equals to -1. For example, if m is 2, m prime would be -½ In that case, the two lines would be perpendicular. Now, that's it for the quick recall on straight lines. Now, let's just move to linear functions. Now, a function is linear if it's a polynomial of degree 1. So f is linear if and only if f of x is equal to ax plus b. So when f of x is written in that form, in the form of ax plus b, where a and b are real numbers, in that case the function will be linear. So linear functions graphically are either oblique or horizontal lines. Vertical lines are not functions because vertical lines do not pass the vertical line test. Okay, while horizontal and oblique lines do pass the vertical line test. So whenever we're speaking of linear functions, we're speaking of oblique or horizontal lines graphically. It's the functions that can be written, whose equation can be written in the form y equals to ax plus b. Now, if we move to this example, now there are a lot of examples and exercises in the book regarding writing equations of straight lines given a point and a slope, or given 2 points. Now, these are exercises that have been covered in previous years, so we're not going to go through them in details here. I'm going to jump immediately to first calculating the intersection of straight lines using the GDC, and in the next example using word problems on straight lines, okay, or on linear functions. So over here we have in this example two straight lines that we need to use the GDC to calculate the point of intersection 2. So we start, let me open the GDC here. So we start by going to graphs. So we start by going to graphs. We type the equation of the first line. It's already y equals to x plus 5. I type the equation of the other line. Now over here, L2 in the example is given in standard form, while over here on the GDC, we need it in the form y equals to mx plus b. So for that reason, you can just rearrange the terms and solve for y. So you would obtain y equals to negative 3 over 2, so that's negative 1.5x, plus 12 over 2, so that's a 6. Okay, so plus 6. And now that I have the two equations, you'd notice that both these equations are selected. So when you press draw, the GDC will draw both lines. If you wish to only draw one of them, you just go, you notice there's the cell above F1, that's for select. So if you press F1, you notice that Y2 is no longer selected. So therefore now when you draw, it will only draw the first line. So the GDC would only draw the lines or the curves whose equations are selected. So over here to find the intersection, we need to have both of them selected and drawn. So by pressing F6, we'd have this screen for the for the graphs of the two straight lines. You notice that the point of intersection is outside the screen, so I just go to view windows by shift view window, shift F3, and fix here for y. I'm gonna choose to scale negative 10, 10 in order to be able to see the point of intersection. Okay, so we press exit and we go again to draw. So now the point of intersection is on screen. Okay, so to find exactly the value of the point of intersection, I go to Shift G-Solve. Now you find here the menu for G-Solve. There's the intersection here, ISCT for intersection. So above F5, so I press F5 for the intersection. And therefore we have the point of intersection here of abscissa 0.4 and 5.4. Now in order to justify your answer using the GDC graphs on paper, it's not enough to just say GDC graphs. You'd have to sketch both lines by highlighting the point of intersection. Okay, now over here I'm not going to draw it by hand, I'm just going to copy the GDC screen. Okay, so going back to the presentation, usually on your paper you just draw the coordinate system, you draw the two lines pointing out which one is which line, and you write down the coordinates of the point of intersection, and then you'd conclude your answer by saying point of intersection is 0.4, 5.4, that's the ordered pair, and between parentheses you just say GDC graphs. But GDC graphs, you'd have to have the graphs sketched in order for your answer to be accepted. Okay, now if we move forward to the next example, now in the next example we have a video, we have a word problem we have 3 parts to this problem. We're going to solve each part separately one by one. Okay, so a video streaming service charges a monthly service fee of £6.99 and an additional £0.99 for each 24-hour download rental of a premium movie. The total monthly cost of this service in Great Britain pound is f of x equal to 0.99x plus 6.99. So basically they gave you the function here representing the cost of the service. However, even if the function was not given, you are able to set up this function by first considering 6.99 as a fixed cost and 0.99, that's the cost of each rented. So you start by defining x to be the number of movies being rented. So in the equation, 0.99 would be multiplied by x plus the fixed cost, which is 6.99. But however, the exercise here gave you the function, so we can start with the questions. So in part 1, they're asking to find the total monthly cost for a month. Of course, they said total monthly, in which there are 5 premium movie rentals. So if during a month there has been 5 movie rentals, that's for X, because X represents the number of movie rentals during that month. So 5 movie rentals, it means that X is equals to 5. So in order to find the cost, which is represented by the function f, all I have to do is just replace x by 5 in f of x. So f of 5 being 11.94, in that case the total monthly cost is 11.94 pounds. Okay, now let's just move to part 2. I'm going to keep the given at the top so we can actually see all the givens we have. So in part 2, they're asking us to find the inverse of f and tell what x and f inverse of x represent, what x in the expression of the inverse represents, not in the original function. So first we're going to start by finding the inverse. Now first we know that the inverse exists because f of x is a linear function. It's graphically represented by an oblique line, and that is increasing, so it's 1 to 1 as well. It passes both the vertical and the horizontal line test. So the function being 1 to 1, then the inverse function exists. So in order to find the function, we start by writing the expression in terms of y and x. We know that f of x is y. So to find the inverse, we solve for x in terms of y. So we start by isolating the term in x, and then eventually we'd get x equals to 1 over 0.99 y minus 6.99 over 0.99. Therefore, f inverse would be, now I replace, or I call y in the expression back by x. It's a variable, I can call it whatever I want. So f inverse of x is 1 over 0.99x minus 6.99 over 0.99. Now I need to answer the second part of this question, which says, in f inverse of x, in that expression, what does x represent and what does f inverse of x represents? Now, if we go back to the expression we have here, before we switched back the variables, so we'd have x representing the inverse and y representing the independent variable in the inverse. Now, originally, y was the cost and x was the number of movie rentals. So up to this point, over here when we solved for x in terms of y, we had the number of movies rented in terms of y, the cost of that month of the service, the cost of the service to that month. Okay, so in fact, over here in f inverse of x, f inverse represents the number of movies rented, and x is in fact the cost of the service during that month. Okay, so in order to be able to interpret your variables, what you have to do is go back to the original variables before you actually swap them or switch them. Okay, so then x represents the total cost and f inverse represents the number of movies rented. Okay, which leads us to the third question that says, find the number of premium movie rentals downloaded in a month where the total monthly cost was 18.87. Now, in f inverse, we said that f inverse represents the number of movies and x represents the total cost. So in the expression of the inverse function, the total cost 18.87 is in fact x, the independent variable. So to find the number of movie rentals, what we do is replace x in f inverse by 18.8, since the inverse function represents the number of movie rentals. So f inverse of 18.8 would lead us to 12. Therefore, 12 movies would cost 18.87 pounds.